Hello, in this video we're going to look at problems from Module 7, Rational Functions. So let's look at the first problem. Find the domain, vertical asymptote, horizontal asymptote, x, and y-intercept for each function. So we always want to find domain first. So first step is to simplify. Simplify as in factor. Factor the functions for if it's factorable. So on the top part, I'm going to factor 2 minus x 2 times x minus 3. Over bottom, we can factor to x minus 3 times x plus 5. So here we're not going to do anything. Just looking at these, we can find domain. So what is domain? It will be negative infinity to negative 5, negative 5 to 3, union 3 to infinity. Or in set Builder notation, it is x such that x cannot equal to negative 5 and 3. So for domain, we just factor and don't simplify anything. Just look at the denominator, and whatever makes denominator 0, we have to exclude those input quantity from the domain. Now we're going to find vertical asymptote. So I'm just going to call it VA for short, vertical asymptote. Now for vertical asymptote, we do have to simplify. So just for purpose of vertical asymptote, we can simplify x minus 3, x minus 3 to get 2 over x plus 5. Okay, we're not saying that this 2 over x plus 3 is same function as the f of x. They're not same function. But just for purpose of finding vertical asymptote, we can simplify. So now simplify, and then whatever makes 0 in the denominator of the simplified expression, it gives us vertical asymptote. So in this case, x equals negative 5. So again, negative 5 also is right here, right? So vertical asymptote values is also not in domain. So keep that in mind. Now let's find horizontal asymptote. Horizontal asymptote has 3 cases. So in this case, the bottom degree is greater than the top one. In that case, we always have y equals 0 as horizontal asymptote. Now we're going to find x and y-intercept. In order to find x-intercept, we have to set function equals 0 and solve. Okay. So if you let function equal 0, we have to let 2. So it is easier to work with the factor form to find x and y-intercepts. 2 times x minus 3 over x minus 3, x plus 5. So we set this equal to 0. And as you notice, whatever number we have in the denominator does not affect being 0. Only way this entire expression can be 0 is if we have 0 over some number. So that means that we can only look at numerator and set numerator equal to 0. So we're going to set this equal to 0. So 2 times x minus 3 equals 0. Then 3 will give us 0, right? But now this is where we have to be careful because 3 is actually not in domain. So for this problem, we cannot plug 3 into the function because 3 is not in domain. So there is no x-intercepts. No x-intercepts. No x-intercepts. Okay, so for B, pause the video and try on your own. And when you come back, I'll go over it. So first, again, try to simplify if possible, as in factor first always. So bottom can factor as this. So what is domain? We have to exclude 3 and negative 3. So domain is negative infinity to negative 3, union negative 3 to 3, union 3 to infinity. And set Builder notation is x such that x cannot equal to negative 3 and positive 3. So we always find the domain first. And then, in order to find vertical asymptote, we simplify just for purpose of 1 over x minus 3. Then whatever the simplified version, denominator makes 0 is vertical asymptote. So x equals 3. So that means that among these two values we exclude in domain, 3 is vertical asymptote. Then what's happening in negative 3? We just have open circle, empty circle. Okay. Horizontal asymptote. Here, bottom has higher degree compared to top degree. So when denominator's degree is higher than the numerators, we just have y equals 0 as a horizontal asymptote. Let's find y-intercept. In order to find y-intercept, we have to plug 0. If I plug 0 into here, okay, and if I simplify, I get 1 over negative 3, which is same as negative 1 over 3. So y-intercept is 0, comma negative 1 over 3. Okay. X-intercept, same idea. We set entire function equal to 0. That means we have to set numerator equal to 0, same as before. Then x would be negative 3. But again, negative 3 is not in domain. So this tells us that no x-intercept in this case. Okay. And knowing that we don't have x-intercept is also helpful. That means that when we graph this, the graph will not touch x-intercept. So let's look at part C. Again, try to factor if possible. We have x minus 2 squared over 2x. Right? Let's find the domain first. For domain, we just cannot have 0. So negative infinity to 0, union 0 to positive infinity. And separate the notation x such that x cannot equal to 0. So that's the domain. Vertical asymptote is, this is as simple as we can make it. We cannot simplify this expression anymore. Therefore, whatever makes denominator 0, so x equals 0, is vertical asymptote. Horizontal asymptote, since degree in the top is bigger, that means there's none. So no horizontal asymptote. And this one actually is degree is exactly 1 greater than this, right? The bottom one. So this one actually has oblique or slant asymptote. And this is the exact same example from the main lesson video I went over. Okay. And in number 2, we'll look at how to find oblique or slant asymptote. So let's find x-intercept. X-intercept. So we set top equal to 0. So x minus 2 squared equals 0. So this part. Because if top 0, 0 divided by entire function will be 0, right? So what makes this 0? When x is 2. Oops, let me write that better. When x equals 2. So that means that x-intercept is 2, comma 0 is an x-intercept. For y-intercept, we just plug 0. But we cannot plug 0, right? Because 0 is not in domain. So no y-intercept. No y-intercept. So we always have to be mindful of domain. Okay, so for number 2, we're going to look at how to find slant asymptote. But in order to find slant asymptote, first we have to know that when we have it. We have slant asymptote when the degree of bottom is exactly 1 less than the top. So when that's the case, we have a slant asymptote. And of course, we don't have horizontal asymptote when top degree is bigger, right? So we're going to do long division. This is just like a regular division you may see in with numbers. So this means that we have 4x to the third minus 4x squared plus 4 divided by x squared plus 4x. That means how many times x squared 4x can go into, right? X third minus 4x squared plus 4. So we set it like this. Then what we do is we see what do I have to multiply to x squared to get x cubed? X, right? Then x squared times x give me x cubed. 4x times x gives me plus 4x squared. Then we're going to subtract. X squared minus x squared gives 0, and it should be always 0. That's the whole point of matching, so we can subtract that. Then negative 4x squared minus 4x squared gives me negative 8x squared. Now then we look at what do I have to multiply? Okay, let me bring this 4 down, plus 4. What do I have to multiply to x squared to get negative 8x squared? Negative 8. Then I get negative 8x squared, and 4x times negative 8 gives me negative 32x. So if I subtract this to be 0, then I have 4 minus negative 32x, which is 4 plus 32x. And this is as far as we can go, because now I cannot multiply anything to x squared to get x, right? So this is the quotient, and this is the remainder. And for purpose of finding slant asymptote, we don't care about the remainder. We only look at this. So that means that linear equation y equals x minus 8. This is a slant asymptote. So that means that for this function, however it looks like, negative 8, here's diagonal line, and here's the asymptote. And the slant asymptote, it can cross. The function can cross as long as the trend of just approaching. It can also cross. And same for horizontal asymptote. It is okay for graph to cross horizontal asymptote. Only asymptote the graph cannot cross is a vertical asymptote. So keep that in mind. Because if it passes the vertical asymptote, it's not a function. Okay. So let's look at number 3. So number 3 is one we did on the previous page, number 1. We already find domain to be negative infinity to negative 5, union negative 5 to 3, union 3 to infinity. Okay, and we found the vertical asymptote for this problem was x equals negative 5. Horizontal asymptote was y equals 0. And f of 0, y-intercept, I guess I might have forgotten the first problem, but we're going to find y-intercept with to plug 0 in, then I get 2 over 5. That means that 0, 2 over 5 is the y-intercept. And we didn't have any x-intercept, no x-intercept. So let's graph these. So here's the key that when you graph, first be mindful of domain. We have to exclude negative 5 and 3, right? So what I like to do is when you graph, mark some points. Here's negative 5, negative 6, negative 7. So at negative 5 and 3, I'm going to highlight it, or since you might not have highlighted when you take the quiz, when you do homework, just put an open circle. Draw a big open circle. Show you that to indicate that when input quantity is negative 5 and 3, we should not have any function, the output value. We should not have any corresponding output value in these two values. But x equals negative 5 is also vertical asymptote. So here we can just draw vertical asymptote lines like this. So we don't have to worry about filling open circle. But for when x equals 3, we should not have any output value. That means that we should have open circle. So if the graph is in here, if the graph is positive, we should have open circle somewhere here. If it's negative, somewhere here. Okay, so we must keep that in mind. So then let's mark some y-intercept. Y-intercept, let's say it's 1, 2, negative 1, negative 2. 2 over 5 is a little less than half, so maybe here's the y-intercept. Okay, so here is 2 over 5. So function will cross here. And horizontal asymptote, let me mark with different color, is y equals 0. So here's horizontal asymptote. Make it thicker to this horizontal asymptote. So let's see, what else? There's no x-intercepts. Now, going back to definition of vertical asymptote, as x approaches -5 from the right side, it either should go positive infinity or negative infinity. Same here, either this or this. So to figure that out, how do you figure that out? We just plug some points. So when you graph rational function, think as you have two parts. In this case, we have one vertical asymptote, right? So we have two parts. We have a section left of vertical asymptote and section right side of vertical asymptote. So we have to draw one section at a time. So think as there's two parts to the graph. If there are two vertical asymptotes, that means we have three-part graph. Okay, so keep that in mind. So let's look at right side first. So for right side, I'm going to plug some points. So that means I'm going to find f of 4. So that means I'm going to plug f of 4 here. Okay. So you can verify this calculation on your own time. So if I plug 4 here, I should get 2/9. If I plug 4, so 2/9. So 2/9 is less than 2/5, so it's be below this point. Maybe lower than this point right here, so somewhere here maybe. And I'm going to plug -3. Still right side of the vertical asymptote. F of -3 will give me 2/2, which is 1. So with -3, we should have 1. So now, let me highlight this. We have 3 points on the right side of vertical asymptote. Right? So if we connect this, we can see the trend. That graph will go this way. So as x approaches -5 from the right side, it will go to positive infinity. And you can also verify, if you plug -4, there's some point here. Okay, so then horizontal asymptote means that as x increases, y value go towards to 0. So like this. Now here, here we must have open circle right here, open circle. And connect this like this. Okay, so we must have open circle around this height to indicate that we do not have a corresponding output. So we just finished one part of the graph. Now let's look at the other side of the vertical asymptote. That means we have to plug some points. Let's say f of -6 and f of -7. Again, I'm just plugging it right here. Okay, so -6 will give me -2. -7 will give me actually -1. So when it's -6, it's give me -2 right here. -7 will give me -1. So this tells us that graph as x approaches -5 from the right side, it will go towards -infinity, and here goes towards 0 as x goes to -infinity, as x gets smaller and smaller. Okay. So we just complete the graph, and let me highlight red both this open circle, this graph, and this. Both the two lines represent this function right here. So this is one graph. We only think as two part so that you will not forget to do the both sides of vertical asymptote. So let's look at this. Again, I'd like you to pause the video and try on your own. At least try to find domain, vertical asymptote, x and y-intercept, horizontal asymptote on your own. Okay, so pause the video, try, and come back. So when you look at these, again, we always try to factor if possible. So I'm going to factor, top cannot be factored, it's just 5 plus 2x squared. Bottom can be factored as 2 plus x, 2 minus x. So now we factor that we can find the domain just looking at the denominator, right? So domain is, we have to exclude -2 and, oops, sorry, this here I meant to write 1. This is factor form. So we have to exclude -2 and 1. So domain will be -infinity to -2, union -2 to 1, union 1 to positive infinity. Or in set builder notation, x such that x cannot equal to -2 and 1. So what I actually like to do, when you find a domain, mark it in the graph right away. Here's -2, here's 1. So here we should not have any corresponding output value because it's not part of the domain. So then let's try to find the vertical asymptote. In this case, we cannot simplify this expression furthermore. So actually x equals -2 and x equals 1 is vertical asymptote. So we can just draw a dotted line. Okay. So then let's find horizontal asymptote. Now horizontal asymptote, if you look at this, we look at the highest degree. We have 2 x squared and -x squared. We have the same degree, right? 2 and 2. When we have a same degree from numerator and denominator, we look at the coefficient of highest term degree. So that means we look at 2 and -1. So we do 2 divided by -1 gives us -2. So horizontal asymptote is y equals -2. So let's also mark that. Let's draw it right away. Here's -2. Remember, it is okay for graph to cross horizontal asymptote. It can also cross it can also cross slant asymptote. But function graph cannot cross vertical asymptote. Okay. So now let's try to find x-intercept. X-intercept. Okay. In order to find x-intercept, we have to let for rational function top part equals 0, which is 2x squared equals -5, x squared equals -5/2. But no number we can square can get negative number in real numbers, right? So again, no x-intercept. No x-intercept. That's okay. That means the graph will just not touch x-intercept. How do you find y-intercept? Just plug 0, f of 0. Okay. And if you plug f of 0, you get 5/2. So 0, 5/2. Again, I'm just plugging 0 here for x, and x. It's 5/2. So maybe 5/2 is a little bigger than 2, so somewhere here. Okay. So now we are ready to graph. Okay. So here again, we look at 3 sections. We have one section, second section, and third section. So look at it as 3-part graph. These 3 parts of graph make whole function graph. Okay. So again, same idea. What we have to do is to plug some points. So let's look at this part first. So let's plug, maybe let's look at f of 2. Okay. So f of 2, let me write it here. F of 2. Again, I'm plugging in 2 to right here. Okay, so that's just algebra, right? So plug 2 there. And f of 2 will give us -9/4. So when it's 2, we have -9/4, which is, if there's -2 here, will be right below -2 right here. Here's -2, right? Y equals -2 is the horizontal asymptote. Okay. So there's the 1 point. Then let's also find f of 3. Okay. f of 3 will give me negative 23 over 10. Okay. So actually f of 2, I think I made a calculation error. It should not be. F of 2 should be actually, sorry about that, negative 13 over 4. I read my paper wrong. Okay. So negative 13, which is about negative 3 point some number. So somewhere here. When it's 3, it's negative 23 over 10, which is negative 2.3. So it's above this number, above this value. So right here. So somewhere here. Again, we're just estimating, right? So negative 2.3 somewhere here maybe. So we have 2 dots. And again, we will have to be mindful of what we know vertical asymptote. As x approaches negative 1, here's negative 1. Oops, sorry. Positive 1, and this is negative 2. As x approaches 1 from the left side, this 2 dots they will go towards like this way. And also go horizontal asymptote like this. Okay. So this is just the one part of the graph. Okay, keep that in mind. This is just one section. Now we have to look at other 2 sections. Okay, so let's look at the middle section. So middle section, we already have this point. Okay, but again, we still have to find more points. So here, let's try f of half and f of negative half. So here's f of half somewhere here and negative half right here. So f of half, again, I'm just plugging x's to right here. So f of half will give me 22 over 5, and f of negative half will give me 22 over 9. So 22 over 5, okay, is about 4.4. Excuse me, 4. Yeah, it is 4.4, right? But again, we don't have to know exact number. We have to know ballpark. So there's 1, 2, 3, 4, a little bigger than 4. So when it's half, it's somewhere here. When negative half right here, it is 22 over 9. 22 over 9 is about 2 point some number. So let's just say ballpark somewhere here. Oops, sorry. But now we have to see if 22 over 9 is bigger than this value right here, which was, where's the y-intercept? 5 over 2. Okay. And it is. Okay, 5 over 2. So somewhere here. Ballpark. Okay. So 22 over 9, let's see. Actually find it. It's about 2.4. And 5 over 2 is actually 2.5. So actually, it is not bigger. Let me just double check my calculation. Okay, yeah, so let me draw it again so my calculation is correct. So it is somewhere here. Okay. Let me actually erase some so we can see clearly. So there's a y-intercept. Negative half will give us some number right here. Okay. And we're going to actually try another point, negative 1. Okay. So now f of negative 1 will give us 7 over 2, which is 3.5. So when negative 1, it gives us, here's 3.5 somewhere here. So we just found 4 points. Okay, so let me highlight that. We found these 4 points. This one, this one, this one, and this one. And this should form a curve. So let me erase those highlight. So this shows a trend again as x approaches -1 from the right side, from the left side, it goes positive infinity. And a curve back, connect, and when x approaches -2 from the right side, it also goes positive infinity. So we have this kind of parabola shape in the middle part by connecting these 4 dots. So lastly, let's look at last section, the left side of -2. Again, same idea applies here when we plug some points, f of -5, f of -3. To this function right here, I'm plugging these numbers. And what do I get for output? I get -55 over 18, and I get -23 over 4. So there's -3 and -4, -5. Okay. So again, this is what we did the warm-up in main lesson, so we can compare the fractions. So -3 gives me -23 over 4. -23 over 4 is slightly bigger than -6, right? So here's -2, 3, 4, 5, 3, 4, 5, 6. Slightly bigger than -6 right here. Okay. How about -55 over 18? Right. So 18 times, we can think as 18 times 3 gives us 54. So this is a little smaller than -3. So around -3 is right here, -3. So -5 will give us a point here, something like this. Again, these 2 points is enough because this shows that these two has to connect and curve. And we know that because of trend of y vertical asymptote, as x approaches -2 from the left side, it will go -infinity. And this will just approach horizontal asymptote. As x gets -infinity, y value approaches -2. So let me highlight the whole graph. All these 3 parts are this rational function graph right here. Graph of this function. Okay. So make sure you know how to find all the information. Domain, vertical asymptote, horizontal asymptote, x and y-intercept, if there are any. Same for the horizontal asymptote, if there are any. And also for vertical asymptote, we don't always have vertical asymptote for polynomials. Some polynomials don't have vertical asymptotes. Okay. Then, important thing is find some points like I did here, here, and here to see the trend.